So once we have our test statistic in mind, we can then talk about our final decision, about what we want to do with our test. We're not just getting all this information for the sake of having it. Like I said, statisticians don't just do this for their fun. Well, some of them do, but usually they're getting paid. And if they're getting paid, they want to be able to give something back, and this is that something, the final decision here, where we can talk about it either in terms of p-values or critical values. But like I said, I prefer p-values. It's what I'm going to focus on more here. We'll see stuff with critical values as well here and later, but this will also explain why I kind of prefer p-values. Anyway, when we talk about these things, our decision is in terms of a comparison between our level of significance and our test statistic. If we get that in terms of a p-value, remember what that p-value represents is the probability of getting our test statistic or anything more unusual, assuming that the null hypothesis is true. Where, if the p-value that we get, that probability, is less than or equal to alpha, our level of significance, which is determined beforehand, then we reject the null hypothesis, we reject HO. I'll say that we include the equals there for the sake of consistency, but the truth is, if you manage to land perfectly on the level of significance, someone's probably playing a joke on you, something weird is going on, it doesn't happen. So don't really worry about that equals to case. Really the important thing is seeing if it's smaller. That's the more reasonable, that's the more meaningful, that's the more usual case, where a couple of my students a few years ago took to a pretty crass mnemonic, but it seems to help some people, where they say that if the p is low, you reject the ho. Hey, if it works, it works. And it's worked for some, so by all means, I have no compunctions about the use of a mnemonic to help you out. Anyway, that's one case. The other case that we have is if the p-value is instead greater than alpha, that is, if the probability of getting our result is large. That says that, maybe it's odd, but it's not odd enough, could just be random chance. So, if p is bigger than alpha, we fail to reject the null hypothesis. Technically speaking, we are not supporting the null hypothesis, because you might get something like a 25% probability, and sure, that's not enough to say that something's definitely incorrect, but it's also not enough to say that this is good either. It's just sort of in the middle. It'll happen very, very rarely that you get a p-value that is particularly large. And as a result, that's kind of why we use this double negative language, because you aren't technically saying it's good, you're really just saying it's not bad enough to toss out what we assumed was fair. So you fail to reject if the p-value is particularly high, and even particularly just high enough to be bigger than alpha. Similarly, we have for critical values, if the test statistic is outside of the critical region, we reject. That's the best phrasing I could give for that. That was kind of clean because it's very much case by case. That's part of why I like the p-value approach better, because it's just, is it big, is it small? Yes or no, we're good. For this, you kind of have to think about where each thing is. For a right-tailed test, you're looking for a critical value that is in the right side, so to the outside is bigger. On the other hand, if you have a left-tailed test, you're looking for things that are further to the left, so smaller, and then for a two-tailed test, which is kind of an odd case that we'll see, you get either, but it has to be on the outside. That's a place called the rejection region or the critical region. Another reason why I don't love the name critical value, I may have talked about this before, is because it kind of doesn't quite fit with the calculus notion of a critical value as well, and I'd like to think that stats should communicate really nicely with calculus for how much overlap there is. But the critical value thing is something that you kind of have to picture in the context of a distribution to really get. So I'm going to try to have some of that stuff going on up here, but truth is, again, p-value is better. We'll still see how to do some of this stuff as well. Now, for the sake of completeness, for the sake of really seeing this in action at least a tiny bit, we're going to get an example here.